Hi, my name is Andrew, and I'll be walking you through my first problem. So in this problem, we're looking at the design of a fermenter for ethanol. So this fermenter has a thermal jacket around the sides, which will come into play when looking at the heat transfer through them. There's also energy generation from the yeast, because this is an exothermic process. And so basically we're going to be trying to maintain the internal temperature of 30 degrees Celsius while the surrounding temperature is 20 degrees Celsius. And then we're going to be trying to find the maximum volume at which this can be attained. To do this, we're going to be looking at the heat transfer through the system, which would be the walls of the reactor. And so this heat transfer can be found in three terms, which would be the conductive heat transfer of the metal tank, the conductive heat transfer of the thermal jacket, as well as the convective heat transfer of just the outer surface area. So once these three are found, you can find total heat transfer through the system, and then using that and the energy generation, you can find the optimal volume for this reactor. Additionally, I ask you how to describe the heat transfer if the thermal jacket were replaced with a heat exchanger like cooling flow over the exterior of the tank. And I included this because it's pretty common for these fermentation bioreactors to include something like that. And so basically, instead of this thermal jacket heat conduction term, this would instead be a heat convection term, which would help you solve the problem pretty similarly. In this problem, we address the learning objectives of heat conduction, heat convection, and heat radiation. We assume heat radiation is negligible in this case. We're dealing with steady-state heat transfer. We use one-dimensional spatial variation to look at the heat transfer throughout the layers of this wall. And we also use a Cartesian coordinate system because that's what is easiest. We use natural convection with this convective term out here, as well as modeling and designing heat and mass transfer unit operations. So basically finding our volume, we're designing this unit operation, which is fermenter. We also use our analytical and numerical problem-solving skills to solve the differential transfer equations to get our final answer. So yeah, there's some sources. Thank you.